In this video, we're going to do this learning target. I know the steps needed to perform stoichiometric calculations and can use them to solve problems. Now we're going to focus on this first little bullet here, define and explain stoichiometry in this video. So let's talk about what stoichiometry is. It's basically a recipe. So if I have a recipe to make a s'more, I need 2 graham crackers, 1 marshmallow, and 1 Hershey bar to make a s'more. So if I have 22 graham crackers and plenty of marshmallows and Hershey bars, how many s'mores can I make? Well, I can figure out that I can make 11 s'mores based on my graham crackers. So see, you can already do this. We just have to use our chemical equations as opposed to a recipe for s'mores. So stoichiometry is the quantitative analysis of our chemical reaction. Quantitative means numbers, so we've got to use math here. And it gives us what we call the theoretical yield, and we're going to be using that in the next learning target. So here's a balanced equation, just a generic equation here, where the lowercase letters are your coefficients, uppercase letters are your compounds. And if we start with some amount of A and some amount of B, we're actually going to start with 0 amounts of C and D. We haven't produced anything yet. We haven't yet mixed our reactants together. So we're going to start with 0 of those. So what happens is, as A and B react together, their amounts are going to decrease until they both get to 0 amount of moles. They're going to be all used up. And at that point, what you're going to have are some amount. You're going to increase your amount of C, you're going to increase your amount of D, and these are all going to be proportional to one another. So in a reaction, the reactants are going to react together, their amounts are going to decrease, and the amount of the products are going to increase. And we can use stoichiometry to figure out by how much. We can use actual numbers here. So here's a little chart that I created. You may not be able to see all of it on this slide because it gets kind of tiny right in here. But I will put this as a picture into the Google folder so you can go in and look at it and print your own if you want to. And I'll have a big one in class also for you to look at. So basically what we're going to do is read our problem, underline and circle. We do need to have a balanced equation. Notice that that's a different color and it's written pretty big. We're going to have a unit plan. We're going to need conversion factors. Yes, we are going to convert to moles here, y'all. Then we're going to use what we call the mole bridge. Those are our coefficients from our balanced equation. That's going to help us to convert between compounds. Then we're going to have moles, and we're going to go back to the unit that's asked for in the problem. Now in these problems it's typically going to be grams. As we go on into gas laws and solutions, it'll be a little different. Then we're going to report our answer with correct units, and then we're done. In this video, I'm going to show you how to solve a stoichiometry problem using the magic number method. Okay, so the first thing, of course, that we want to do is read our problem and underline and circle anything that we're trying to find and anything that we're given. So how many grams of sodium chloride, now we need the whole thing because it's important to know grams of sodium chloride, can be formed when 10 grams of sodium react with chlorine gas. Now the reason we need to know that it reacts with chlorine gas is so that we can write a balanced equation. So remember that you must have a balanced equation. Okay? So what I'm going to do is label my balanced equation. So I'm looking for grams of sodium chloride, that's NaCl, and I start with 10 grams of sodium, which is Na. Now what I'm going to need to find my magic number here and to solve this problem, I'm going to need moles, molar mass, and grams. So what we're going to do is take our coefficients, our 2, our 1, and our 2, and we're going to write those in the mole column. So that is 2, 1, and 2. All right, and I'm going to put an X behind each one. Okay, now what we're going to do is solve for X, and that's going to be our magic number. So let me show you how we do that. So to find X, we are going to need our molar mass. So remember that that comes from the periodic table. So sodium, the mass of 1 mole of sodium, remember that this is grams per mole. Okay, that's 22.99. So I'm actually going to round to 23 here because that makes my math a lot easier. Now, chlorine I don't actually have to calculate anything for, but I'm going to go ahead and do it and just show you. Because you've got 10 grams of sodium, we're looking for sodium chloride, so we don't really need our chlorine. But we're going to go ahead and do that. So for chlorine, let me just show you. Remember, it's Cl2, so that means we have 2 chlorines times 35.45 mass from the periodic table, so we get 70.9 grams per mole. So that's where that number's coming from. So I get 70.9. If you wanted to round to 71 there, you could. Okay, that box keeps disappearing. Sorry about that. And so for sodium chloride, same thing. We're going to add up our 1 sodium and our 1 chlorine, and we get 58.44. So now to find our grams, what we're going to do is take our moles, and we're going to multiply by the molar mass. All right, so moles times molar mass equals grams. So we have 2x times 23, and so that gives me 46x, okay? So I did 2x times 23, gives me 46. So 1x times 70.9 gives me 70.9 times x. 2x times 58.44 is going to give me 116.88x. All right, now I need my x factor. I need the x. Okay, so to solve for x, all right, that's our next step. Solve for x. What we're going to do is take our given value of 10, and we're going to say 10 is equal to 46x. So we're going to use this column right here to find our x factor, our x value. So if I divide both sides by 46 and solve for x, I end up with 0.217. Now what I've actually found here is moles of sodium chloride. Okay, and that's going to, it's my mole ratio. Okay, and so I can use that x to calculate my grams of chlorine and my grams of sodium chloride. Now I don't actually need grams of chlorine, but I'm going to go ahead and do that anyway. So 70.9 times 0.217, that's going to give me an answer of 15.4 grams. If I do the same thing here, if I do 116.88 times 0.217, that's going to give me 25.4 grams. Now my question is asking for grams of sodium chloride, so this is my answer here. I produce 25.4 grams of sodium chloride if I start with 10 grams of sodium. Alright, so let's see another problem. So let's read our problem. What mass of aluminum chloride is needed to produce 78.2 grams of HCl? So let's pull the pieces that we need. We have 78.2 grams of HCl. We're looking for mass. Mass is in grams. So how many grams is going to go there? Alright, so now I need my moles. Now I'm only going to do AlCl3 and HCl. Okay, that's all I have to do here because those are the only two that I need in my problem. I have to have the other two because I need a balanced equation. Okay, so don't forget that that's the most important piece, is to get that balanced equation. Alright, so I'm going to say 2x, because I have a 2 there, and I'm going to say 6x for HCl. Now I could do 3x for H2SO4 and 1x for aluminum sulfate. Aluminum sulfate. So I'll go ahead and write that, but we're not going to actually use it in the problem. Alright, so now I need my molar mass. So for aluminum chloride, I've got 1 aluminum and 3 chlorine times my molar masses. I'm going to add all of that up, okay, and so I'm going to get 133.33 grams per mole. I'm going to do the same thing for HCl. I have 1 of each. Okay, and I'm going to get 36.45 grams for HCl. So there's where my numbers are coming from, 133.33 and 36.45. Alright, so now to get grams, remember that's going to equal your moles times your molar mass. Okay, so 2 times 133.33 gives me 266.66 times x. 6 times 36, all right, so remember we're multiplying here. All right, multiplying here. 6x times 36.45 is going to give me 218.7 times x. So now I need to solve for x. So I'm going to use my given information here to do that. Okay, so I'm going to get 78.2 is equal to 218.7 x. So when I divide both sides, I get x factor of 0.36. So x is my magic number here. I'm going to take that over here and plug it in. So 266.66 times 0.36 is going to give me an answer of 96 grams of aluminum chloride. So there's how to solve stoichiometry problems using the magic number method.